Welcome to the series of video lectures on the subject analysis and design of algorithm. In last video lectures we have discussed the complexities, that is the time complexity and space complexity. पिछले लेक्चर में हम लोग ने ये डिस्कशन किया था कि किसी भी एल्गोरिथम के लिए लगने वाले जो टाइम कॉम्प्लेक्सिटी का कैलकुलेशन है दैट कैन नॉट बी अचीव्ड because it depends upon any number of n number of factors. Now as we cannot get the exact value, we can have an approximation of that. हम लोग ने उसके लिए दो तरीके अपनाए थे. हम लोग ने काउंट कैलकुलेट किया था स्टेटमेंट्स का और उसके लिए एक काउंट वेरिएबल इंट्रोड्यूस किया था और दूसरा s/e दैट इज स्टेटमेंट पर एग्जीक्यूशन और फ्रीक्वेंसी का मल्टीप्लिकेशन करके और फिर काउंट हम लोग ने कैलकुलेट किया था. आज का जो डिस्कशन है वो असिम्प्टोटिक नोटेशन पर है. ये असिम्प्टोटिक नोटेशन भी हमें इनएग्जैक्ट कैलकुलेशन करके देगा, या हम ये कह सकते हैं कि जो भी फंक्शन है जिसके लिए हम एल्गो बना रहे हैं वो किस तरीके से ग्रो हो रहा है उसके बारे में हमें इंफॉर्मेशन दे सकता है. जैसे फॉर एग्जांपल कोई फंक्शन है वो लीनियरली ग्रो हो रहा है, या वो फंक्शन n के पावर्स में ग्रो हो रहा है, या वो कॉन्स्टेंटली कांस्टेंट है. इस तरीके से हम लोग टाइम का इवैल्यूएशन एग्जैक्टली तो नहीं बट अप्रोक्सीमेशन कर सकते हैं, और उसी के लिए उसी की इंफॉर्मेशन देने के लिए उन फंक्शंस की स्टडी करने के लिए हम लोग असिम्प्टोटिक नोटेशंस को यूज करते हैं. नाउ देयर आर थ्री बेसिक असिम्प्टोटिक नोटेशन. वन इज बिग OH that is represented by big O, another is big omega that is represented by this omega symbol, and another is the theta. Now this big omega basically specifies the upper bound, this big omega specifies the lower bound, and the theta specifies the middle in between the upper bound and the lower bound. Now what does it mean? इसके लिए हम लोग यहाँ पर मैथमेटिकल कुछ कैलकुलेशंस करते हैं. फर्स्ट ऑफ ऑल वी विल डिफाइन व्हाट इज बिग OH and how it is defined. So in that we will be having two functions, that is non-negative function fn and gn, and we will talk about two positive constants, that is c and n0. Now let us define big OH. The function f of n is known as big O of g of n if and only if there exists two positive constants c and n0 such that f of n will always be less than equal to c into g of n for all n greater than equal to n0. So this is how we can define big OH. Mind it, यहां पर आपको एक बात ध्यान रखनी है, वो ये कि जो फंक्शन fn और gn है वो नॉन नेगेटिव फंक्शंस है और इसी तरीके से c और n0 पॉजिटिव कांस्टेंट्स है. Now this function basically big OH represents the upper bound. This can be understood by this diagram. Here I have mentioned three diagrams. It is representing big OH. Big OH को represent कर रहा है. यहाँ पर प्लॉट में we have plotted n, that is the input, and this is the function. In that case, this is the function, that is fn, and this is the function c into gn. C is the positive constant. Now we have to find the value of n0 such that for afterward that n greater than n0, मतलब n0 से ज्यादा वैल्यूज के लिए ये फंक्शन हमेशा सेटिस्फाई हो या ये फंक्शन हमेशा ट्रू हो. यदि हमने ऐसा प्रूव कर दिया, इसका मतलब हम कह सकते हैं कि f of n is big O of g of n. Now take some mathematical example to prove that. Taking the first example, let's say f of n is equal to 3n plus 2, and we have to prove that whether it is big O of n or not. इस तरीके से यदि आपके पास कोई क्वेश्चन है तो आपको इसको सॉल्व करने के लिए कुछ स्टेप्स के थ्रू होके जाना पड़ेगा. हमें यहां पर दो पॉजिटिव कांस्टेंट्स ऐसे इवैल्यूएट करने, दैट इज c एंड n0, जो इस कंडीशन को सेटिस्फाई करें. इस प्रॉब्लम को सॉल्व करने के लिए आपको कुछ ऐसे स्टेप्स लेने हैं. Assume that when n is at least 2. Now what is that? ये जो n की वैल्यू है, जो भी यहां पर पॉजिटिव कांस्टेंट आपको मिला है, उस वैल्यू को आप अज्यूम करिए. और फिर let us take fn is equal to 3n plus 2. And now n is at least 2 means we can write like that. That is 3n plus. Now instead of 2 I will just put this value n, and hence the symbol less than equal to will be there, because this n can be any value, but this 2 is the least value for which n, and this actually is going to become n0 for us. So now substituting this value n in place of 2, this statement will become this one, and this will be less than equal to 4n. So in all मैं इसको ऐसे लिख सकता हूं, that is f of n is equal to 3n plus 2 less than equal to 4 into n. That is f of n is equal to 3n plus 2 less than equal to, that is c into gn. Here this, यहां से हम ये देख सकते हैं कि c is equal to 4. This is the value we have obtained, and n0, that is equal to 2. We can say that this f of n is big O of g of n. Why? Because we have obtained two positive constants, that is c and n0, जिसके लिए ये फंक्शन हमेशा सेटिस्फाई करेगा. अब इसे प्रूफ करने के लिए कि ये सेटिस्फाई करेगा या नहीं करेगा, we can take some values. हमें इसको चेक करना है. Let's say n is equal to 1. तो यहां पर 3 into 1 plus 2 less than equal to 4 into 1, that is 4. Now 3 into 1 is 3, 3 plus 1, 3 plus 2, that is 5. So यहां पर this condition gets failed. Okay. Now put n is equal to 2. N is equal to 2 means 2 into 3, that is 6. That is 6. I can directly write 6. Then plus यहाँ पर 2 less than equal to 4 into 2, that is 8. Now 6 plus 2, that is 8, less than equal to 8. This condition is true. Okay. Now next put n is equal to 3. If I put n is equal to 3, that is 9 plus 2 less than equal to, if I put 3 over here, that is 4 into 3, that is 12. This condition will again be true. N is equal to 4, that is 4 into 3, 12 plus 2, 14 plus 14, 14 less than equal to, now 4 into 4, that is 16, and so on. हम लोग ये देख सकते हैं कि n, यहां जो n0 है, this is n0, जो कि 2 आ चुका है. तो n0 मतलब 2 और 2 से ज्यादा की वैल्यूज के लिए ये फंक्शन हमेशा क्या होगा? ट्रू. इसके पहले की वैल्यू के लिए फंक्शन फॉल्स होगा. सो दिस इज इंडिकेटिंग दैट वी आर करेक्ट. वी हैव प्रूव्ड इट. ओके. हियर इट इज बेसिकली 12 plus 2, that is 14. So this is all. So this is how we can prove. Now take another example. If we talk about, now take the second example. Let's say fn is equal to 10n square plus 4n plus 2, and we have to prove that it is big O of n square. Now again, what is the process? Process is same जैसे कि हमने अभी थोड़ी देर पहले लिखा था. यहां पर आपको n 3n plus 2 दिया था, इसलिए हमने n को एटलीस्ट 2 माना था. बिल्कुल सेम प्रोसेस आपको यहां पर भी लेना है. Let's say f of n is equal to 10n square plus 4n plus 2. Now first solve this part and write when n is at least 2. Substitute this value. So f of n is equal to 10n square plus 4n plus 2 less than equal to, why? Because this is at least. So यहां पर जब मैं इसको सब्स्टिट्यूट करूंगा तो 10n स्क्वायर प्लस 4n और 2 की जगह क्या सब्स्टिट्यूट करूंगा मैं? n. And if we solve that, this will become 10n square plus 5n, that is 10n square plus 5n. Now, we have the function fn is equal to 10n square plus 4n plus 2 less than equal to 10n square plus 5n. Now this is the expression. Again we have to solve this. Now this is 10n square plus 5n. For that we again assume that when n square is at least 5. So then what will be the substitution? 10n square plus 5n will again be less than equal to 10n square plus. Now here instead of this 5, now here this is 5n. So from here we can get the value of, that is n0. So n0 here will become 5. So here we will put n square. So in place of 5n I have written n square. So this will become 11n square. So now 10n square plus 5n will less than equal to 11n square. We have obtained this one. Now this is C and this is n is equal to n0 is equal to 5. So again we have obtained two values, two positive values, that is n0 is equal to 5 and the constant C11, and for n is equal to or n greater than equal to n0 means n की 5 या 5 से ज्यादा वैल्यू के लिए ये फंक्शन हमेशा ही क्या होगा, ट्रू होगा। और चूंकि हमने ये दोनों ही वैल्यू फाइंड आउट कर ली है इसीलिए हम लोग ऐसा कह सकते हैं कि दिस इज ट्रू, वी हैव प्रूव्ड इट। इन द सिमिलर फैशन वी कैन टेक सम मोर एग्जांपल्स। Okay, next example I should take here again. Okay, let's say this is third example. Let's say fn is equal to, we are having 6 into 2 to the power n plus n square, and we have to prove that it is big O of 2 of n. Now how can we process that? Okay, for that again fn is equal to 6 into 2 to the power n plus n square. Again write when 2 to the power n is at least n square. Then what will be the definition? Then fn is equal to 6 into 2 to the power n plus n square, that will be less than equal to 6 into 2 to the power n plus, now substitute 2 to the power n in place of n square, it will be 2 to the power n, and less than equal to 7 2 to the power n. 7 into 2 to the power n. So what is that? That is f of n is equal to 6 into 2 to the power n plus n square less than equal to 7 into 2 to the power n. Okay. Now for this, if we put the values of n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, we can obtain the values one by one. So take the first value, 6 into 2 to the power 1 plus 1 less than equal to 7 into 2 to the power 1, that is 2, means 6 into 2, that is 12 plus 1, 13 less than equal to 14. So this is 13 less than equal to 14. The condition is true. Now n is equal to 2, 6 into 2 to the power 2, that is 4 plus 2 to the power 2, that is 4 less than equal to 7 into 2 to the power 2. So that will be 6 into 4, 24 plus 28 less than equal to 2 to the power 2, that is 4 into 7, that is 28. Again the condition is true. For n is equal to 3, again put the value, 6 into 2 to the power 3, that is 8 plus n to the power 3 to the power 2, that is 9 less than equal to 7 into 2 to the power 3, that is 8. So that will be 6 into 8, that is 48. So 48 plus 9, that is 57 less than equal to 56. Now here the condition is failed. Here In previous two cases the condition was true, but in this case the condition is failed. Now for n is equal to 4, again put the value, that is 6 into 2 to the power 4, that is 16, plus now n, that is 16 less than equal to, what will be the value, that is 7 into 2 to the power n, that is 16. Now this will again be true if we solve. For next values this will always be true, you can check it. So here we can obtain the value of n0. Value of n0 will be 4. Means n की 4 या 4 से ज्यादा वैल्यूज के लिए ये फंक्शन हमेशा से ही ट्रू होगा, and hence we can say that this f of n is big O of 2 to the power n and so on. हम ऐसे कई तरीके के एग्जाम्पल ले सकते हैं जिसको हम सॉल्व कर सकते हैं और प्रूव कर सकते हैं कि एनी फंक्शन इज बिग ऑफ g of n. Now we should move further the big omega. For big omega only this condition changes, otherwise everything will be same because it is lower bound. So again for two non-zero functions, non-negative functions fn and gn, f of n will be big omega of g of n if and only if there exist two positive constants c and n0 such that f of n is greater than equal to c into gn for all n greater than equal to n0. This is the definition for big omega. Okay. Now again we should see the graph of that. This is big omega. We have plotted f and n. For that, let's say this is the function fn and we have to obtain c into gn which will cross at n0 और इस n0 की वैल्यू के लिए या इसकी बाद की सारी वैल्यू के लिए, दैट इज द कंडीशन, n की n0 से ज्यादा की वैल्यूज के लिए ये फंक्शन हमेशा ट्रू होगा. मींस fn की वैल्यू c इंटू gn से हमेशा ज्यादा ही होगी. सो दिस इज स्पेसिफाइंग द लोअर बाउंड. हमने पहले भी देखा बिग O अपर बाउंड बताता है और बिग ओमेगा लोअर बाउंड बताता है. सो नाउ अगेन टेक सम एग्जांपल्स, जैसे कि हमने पीछे लिए हैं यहां पर, यही एग्जांपल हम लोग यहां सॉल्व करने की कोशिश करते हैं. लेट्स से fn इज इक्वल टू 3n प्लस 2 एंड वी हैव टू प्रूव दैट दिस इज बिग ओमेगा ऑफ n. सो हाउ कैन वी प्रूव? इसका प्रूफ ज्यादा आसान है. वो कैसे देख लेते हैं. That is f of n is equal to 3n plus 2 will always be greater than equal to 3n. बड़े आसानी से हम लोग ऐसा कह सकते हैं because due to this plus 2, यहां जो वैल्यू है और यहां जो वैल्यू है इन दोनों में ये वैल्यू सेम हो सकती है बशर्ते कि यहां 2 ना हो, लेकिन यहां 2 है तो इसलिए ये फंक्शन हमेशा से ही बड़ा होगा किससे? 3n से. नाउ we have obtained this is as c. Why? Because this is fn is equal to 3n plus 2 greater than equal to c into gn. So what is c? So c is equal to 3. What is n0? जैसे कि अभी बात हो रही है n की हर वैल्यू के लिए, n की 0 वैल्यू के लिए भी ये फंक्शन ट्रू होगा. बट चूंकि हमने कहा है कि c और n0 पॉजिटिव कांस्टेंट्स होने चाहिए, इसीलिए हम n0 की वैल्यू ऑब्टेन न करके या न लेके हम n0 की वैल्यू क्या लेंगे? 1. मींस n0 की 1 या 1 से किसी भी वैल्यू के लिए ये फंक्शन हमेशा से ही ट्रू होगा और इसीलिए हम कह सकते हैं कि f ऑफ n इज इक्वल टू बिग ओमेगा ऑफ g ऑफ n. सो इसका प्रूफ ज्यादा आसान है. ठीक है. Now take the second example जो कि हम लोग ने यहाँ सॉल्व किया है. What is that second example? That is f of n is equal to 10n square plus 4n plus 2 and we have to prove that it is big omega of n square. नाउ इसे भी हम लोग कैसे प्रोसेस कर सकते हैं, ये भी आपको साफ नजर आ रहा है कि this 10n square plus 4n plus 2 will always be greater than equal to 10n square. Why? Due to this term. This is additional term. So ये function हमेशा से क्या होगा, true होगा. Again this is basically c. How? This is fn is greater than equal to c into gn, that is fn square. So here we have obtained the value of c as 10 and again n0, what will be n0? So n0 is again 1. ठीक है, ये 0 के लिए भी ट्रू होगा, लेकिन जैसे कि हमने कहा 0 वैल्यू हमें अलाउड नहीं है, हमने पॉजिटिव कांस्टेंट्स के लिए कहा, इसलिए n0 की वैल्यू हम लोग क्या लेंगे 1. So this is how we can prove that. We can take this example also, that is the third one, third example. That is f of n is equal to 6 into 2 to the power n plus n square, and we have to prove it as big omega 2 to the power n. Again it is easier. 6 into 2 to the power n plus n square will always be greater than equal to 6 into 2 to the power n. Why? Because again due to this term. So here again this is c, and as always n0 will be 1. So this is how we can prove for big omega. Now next, that is the last representation, that is theta. Now as we have already said that the theta is actually the middle bound. It is in between the upper bound and the lower bound. So for that we can define, this will be for the function, again the same function fn and gn, that is the non-negative functions, and we will say that the function f of n is equal to theta of g of n if and only if there exists three positive constants, that is c1, c2, n0. These are the constants. So again we repeat, the function f of n is equal to theta of g of n if and only if there exist three positive constants c1, c2 and n0 such that c1 into g of n is less than equal to fn less than equal to c2 into g of n. For all n greater than equal to n0. This is the definition for that. Means this is upper bound, this is lower bound, and this is the middle bound. So if I have proved upper bound for the same example, if I have proved the lower bound for the same example, again I can always prove for the theta. Take a single example for that. बाकी एग्जाम्पल्स आप सॉल्व कर सकते हैं. जैसे फॉर एग्जाम्पल इसी एग्जाम्पल की यदि हम लोग बात करें, इसी एग्जाम्पल की बात करें तो हम क्या लिख सकते हैं, दैट इज वी हैव टू प्रूव f of n is equal to theta of n. We have to prove that. So what is f of n? F of n is equal to 3n plus 2. So we will proceed like that. पहले हम लोग इस बाउंड की बात कर लेते हैं. तो हम लोग ने जैसे यहां पर दिख रहा है आपको, that is for that n0 is equal to 0, sorry, instead of that we will take 1, and c1 is equal to 3. This is the value, c1 is equal to 3. Now for this upper bound, ये किसके लिए हुआ, lower bound के लिए. For upper bound this is the solution, and we have obtained, that is n0 is equal to 2, and here instead of c we will write c2, so c2 will be equal to 4. Now we have to obtain the single n0. c1 and c2 we are having, that is the upper bound. Now in case of n0 हमने पहले भी देखा है कि लोअर बाउंड में n0 हमेशा क्या आ रहा है, 1. इसलिए we can remove that and here we have obtained the three positive constants, that is n0, c1 and c2, for which this function will always be true. Now how can I define that? तो मैं यहाँ लिख लेता हूँ, यहाँ पर जैसे कि लिखा हुआ है, that is c into gn is 3n. So 3n is less than equal to fn, यहाँ से हम लोग ले लेते हैं fn लेस देन इक्वल टू, और यहाँ की जो डेफिनेशन है वो कौन सी थी, दैट इज 4n. दिस इज 4n. Okay, so this is C1, this is C2, and what is N0? That is 2. So हम लोगों ने सारी वैल्यूज फाइंड आउट कर ली है, इसलिए हम लोग कह सकते हैं कि ये जो फंक्शन है दैट इज थीटा ऑफ g ऑफ n. So बाकी के जो दो एग्जाम्पल है वो भी आप ऐसे ही प्रूव कर सकते हैं, क्योंकि हमने उसके बिग ओमेगा और बिग OH के सॉल्यूशंस ले लिए हैं, आपको सिर्फ उसको इसी तरीके से मेंशन करना है. नाउ इसके अलावा दो और नोटेशन होते हैं, दैट इज लिटिल o, लिटिल, एंड अनदर इज लिटिल ओमेगा. व्हाट इज दैट? इफ वी टेक द logarithm of that, so little OH will be defined as, that is written as little o of n is equal to, that is limit n tends to infinity, that is fn upon gn is equal to 0. यदि ये कंडीशन सेटिस्फाई होती है तो दिस इज लिटिल OH, and another is little omega, that is written as like that, and that is limit n tends to infinity, this will be gn upon fn is equal to 0. So this is all about the different asymptotic notations. Please do like, share and comment, subscribe my video channel. Don't forget to press the bell icon. Thank you.